So we're back after our spring break for our next e-learning day. This is for Monday, March 30th. We're going to do a quick review on the stuff that we talked about and learned from our last e-learning week. Please, as noted in the directions of the Canvas lesson page, please try these problems beforehand, before you watch the screencast, for help. All right, it'd be best if you can try to remember it and then see what you can come up with first, and then come back and look at the screencast second. So I'm going to take a pause right now, so try and go back and try these problems before you listen to the screencast. Okay, so hopefully you've done that, and you're back to get some help if you're having some problems. So here we go. All right, so the first question we have, a bank offers 3.75% interest on a savings account compounded annually. Now the big key for this is the compounded. Okay, it's a compounding problem, so that means we have a specific equation for this. Okay, our equation is a of t for the amount over time is equal to the principal, or the original amount, times 1 plus or minus. Okay, the plus is if we're increasing, the minus is if we're decreasing. All right, and then we have r over k to the k times t power. Okay, so now I got to fill in this stuff based on what we're given, what information we're given in the problem. Okay, so Brian starts off with $1,800. That's his original, his principal. Okay. All right, now because we are adding, we're increasing our amount. We're going to add 1 plus. We're going to change our percentage into a decimal. 0.0375, all right, to the t power. Now you'll notice we got rid of the k and the t, or sorry, the k in the problem, because it's annually, so it's just once a year. So the k is a 1, so we don't really need it in the problem. Okay, if we had every month, then we'd have the k would be 12. It was every week, it would be 52, so on and so forth. Okay. All right, the other thing that's important is when we're doing the since, that means we don't have to include the year that we start with. So 2020 is not included in our time frame. So we're going to have 12 years total if we're doing B, okay, because we're going from 2020 to 2032. So we plug all that stuff into our equation. 1,800 times 1.0375 to the 12th power. All right, and then we can figure out on our calculator what that's going to be. I don't really like going back and forth into the calculator function that we had using last time, because I just think it takes too long to do, so I'm just going to do it on my own calculator. So if you can go back to the, Calculate 84 app that we downloaded before all this craziness happened, that'd be fine. But if we put it in there, we're going to get $2,799.82. We're going to round up. And there's our answer. Now again, this formula is based on the fact that we're compounding annually, or compounding interest, okay? The annually tells you what the k value is, okay? Since annual, it's once a year, and k is going to be 1, okay? All right, number 2. Okay, at 10 a.m., the amount of acetaminophen, which is the chemical compound of Tylenol, in a person's body is 500 milligrams. Each hour, the amount of acetaminophen decreases by 11%. Okay, so we're going to be using the same basic equation as before, okay, but we're doing in hours. Okay, and actually, I lied. We're not doing the same basic equation because it's not compounding. Okay, there's no compounding in this second problem, so it's going to be a different type of equation. Okay, so we're going to have the amount over time and hours, and we're going to do the original, which is 500 milligrams. Okay, and now because we're decreasing, all right, what we're going to do is we're going to take 100%, and we're going to subtract 11% from that, and that's going to give us 89%. Okay, so we have 100% minus 11%, we want to know how much is left. Not how much we're taking away, but how much is left. That gives us 89%. So, as we're doing this, we're going to put in 0.89 for our values for our rate. Okay, and then we're going to do to the h power. Okay, so now we can plug that back in to our equation here. So we have a of h is equal to 500 times 0.89 to the, let's see, so from 10 to 1 is going to be 3 hours. So again, we can plug that into our calculator. So 500 times 0.89 to the 3 hours is, you're going to have 352.48. What are we doing? Milligrams. Okay. There we go. Again, we are subtracting, or since it is decreasing, we are subtracting the percentage. All right. Okay. Next is number 3. All right. So now we have the population of the city of Whoville. It's approximately 25,600 in the year 2014, and has been continuously growing. Okay. So continuously is, again, a separate equation, right? Continuously means it's doing all the time. There is no stopping. It's not annual. It's not weekly. It's not monthly. It's continuous. Okay, so our equation is going to be a little bit different. Again, all right, so it's a of t is equal to the principal, all right, and because it's continuously, it's going to be that e value, all right, and then our rate is going to be a r to the t power, or r times, it's the power of r times t. There we go, that's what I meant to say. Okay, so now all we have to do is figure out all those pieces and put them in place. So we have a to the t. The principal is going to be the number, or the population. So 25,600 times e. The rate is going to be 1.1%, so we're going to change that to a decimal. It's going to be 0.011. And then we have a t for time, because in this case, so far, until we get to b, we don't know the exact time or frame we're looking at. Okay. Now in part b, using that function, so we have a of t is equal to 25,600 times e to the 0.011. And the t value, since it's since 2014, we don't have to use 2014, so we can just use 7 years. Okay, so we're going to put in times 7. Again, I'm just going to do this on my own calculator. So you have 25,600 times e. Remember, e is a specific button in the calculator. It is above, you got to hit second and then the divide sign. All right, raised to the 0.011 times 7. So you'll get 27,649. And we're going to round down because you can't really split a person in half or in pieces. Well, I guess you could, but that'd be gross. So we're going to leave it like this. All right, so those are the exponential problems we've been doing that we did last week before spring break, all right, as e-learning. Okay, so it's kind of a review of those. All right, the rest of the questions are basically just reviews of stuff we've done